Lord, I have my microphone on mute. Good God. Okay. So today we're going to go over 1.5, which is a review of solving quadratics. Solving quadratics is something you should already know how to do. I teach this as a review, and I really kind of tackle it that way. Then we're going to go over 1.7, which is a short section, really just to go over how to utilize interval notation and how you're not just your book, but also myself, but how we both utilize and notate answers that aren't just single, points or coordinates or single values. Okay, so let's look at quadratics. I am going to, and this is one of those math is not a spectator sport. I'm going to put up some examples of quadratics to solve, and I want you to attempt them, okay? And I'm going to give you a few minutes to attempt each one. I'll give you probably like 2 or 3 at a time. And I just want you to try them because this is really a review lecture, okay? And then if you fail, that's fine. It's not a big deal. That's fine. We're going over it. But I want you to try either way because I need you to know how to factor completely. You got to know how to factor. I need you to know how to solve by the square root method, and I need you to know how to use the quadratic equation, okay, or quadratic formula. Those are the 3 topics we're going to go over today with solving these quadratics. So the first few examples, these first few I'm about to put up, I want you to solve by factoring. Okay, so let me move over to my document camera. There we go. Okay, and I want you to solve these 3 by factoring. So the first one, let's say we've got x squared. I'm stealing these from the evens and the homework. X squared minus 13x plus 36 equals 0. For number 2, let's do it's number 10, 5x squared. I'm going to change it up a little bit, equals 20x. And then number 3 over here, let's choose number 8. 4x squared minus 13x equals -3. So I want you to try those 3, and I want you to solve by factoring on these, okay? Don't use the quadratic equation. I want you to solve by factoring. I'm going to give you a minute. I'm going to give you probably like 10 minutes to work these, okay? So if you're working from home, you can hit pause and fast forward whenever and find out when I keep going. But try those, okay? Give me some good attempts on these. Maybe I'll find some good background music. I'm not sure what good solving quadratic background music is, but I'm open to requests. Okay, I'm going to start on the first one. If you're still working, keep working. Start on this first one. This one's a little easier because x squared is by itself, and you can put it in automatically in parentheses. And we already have 0 on one side. So we have to find two things that multiply to give me positive 36, add to give me negative 13. Oh, that's minus 9 and minus 4. So if you FOIL this out, you're going to wind up with this trinomial, right? So then we get x minus 9 equals 0, x equals 9, x minus 4 equals 0, x equals 4, right? There's our two solutions. Now I want you to be careful and notice the degree of the polynomial that we got this from is actually the number of solutions we have. The degree of this polynomial is 2, and the number of solutions we have is 2. Okay, that's not a coincidence at all. Okay, all three of these actually have a degree of 2 because they are quadratics. Quadratics have a degree of 2, and because of that, they're going to have two solutions. Okay, so for this second one, you got to be careful. If you're going to solve by factoring, we've got to have 0 on one side of the equation. So I'm going to subtract the 20x. Now for this one, it doesn't factor like the previous one where we have two binomials. On this one, we've just got to factor out the greatest common factor. We can factor out 5 and then an x out. And we're left with x minus 4 equals 0. These are two solutions, or two factors. So we set them equal to 0. And we get divided by 5. We wind up with x equals 0. Add the 4. And we wind up with x equals 4. Okay, so we've got the two solutions. So we have, again, two solutions. And look, you can check these. If you check 0, you plug it in here. 5 times 0 squared is 0 equals 20 times 0, which is 0. So they're equal on both sides, right? 4 would be the same thing. 4 squared 16 times 5 will equal whatever 20 times 4, so 80. Okay, so you can check those both ways. Again, I'm not going into detail about lecturing about this because it's a review, right? We should know how to do this already. But I'm just going to go teach it with a few, or not teach it, but review it with a few examples. This one's a little different though, because we've got a 4 in front of the x squared. Over here, I did not have a number. Actually, I had a 1, right? But I didn't have a number other than 1. And if we have a number in front of here, I like using what's called the AC method. This is also called factoring trinomials by grouping. I ran out of room there. By grouping. Either one of those, if you looked up either one of these, you would see this method. So if you've never seen this before, or if you know how to factor it, don't worry about it. Just factor however you need to. But if you don't know how to factor this, I would tell you to look up how either one of those on YouTube and just review it. But first we do 4 times 13, or 4 times 3, which is 12. Then we see what two numbers multiply to give me the 12, but add to give me the middle number. Well, that's -1 and -12. And then I split apart the middle number. 4x squared minus 12x. Put that together, plus -1x plus 3 equals 0. Okay? Notice the -12 and the -1x, when you add them together, you get the -13x. This has to happen for this to work. And then we factor the first set of parentheses. We factor 4x out. We get x minus 3. These have to match, and they don't. Right now, the signs are different. See how the signs are opposite? -x, positive 3, -3. So I'm going to factor out a -1, and it changes the signs. Then I can factor out the x minus 3, and I'm left with the 4x minus 1 equals 0. I set both of those equal to 0. So x equals 3. 4x minus 1 equals 0. Now I solve this one. Add the 1, divide the 4. You wind up with 1/4. Okay? And those are our two solutions. So 3 and 1/4. Again, if you've never seen this before, it's called factoring trinomials by grouping, or the AC method. That's just a quicker way to say it. But that is what's going on. Okay. And these are three really good examples of solving by factoring. Actually, I'm going to do two more that are kind of special examples, but we've got factoring trinomials when x squared or when a equals 1. We've got just factoring by the greatest common factor. And then we also have factoring trinomials when a is not 1. Okay. And then, so now let's do two more that are a little different. I guess you could say are a little different. 1, 2, 3, 4. Not sure if your book even does one like this, but I know it uses it later. So let's say we had 4x squared equals 25. And then 5, let's do x squared minus 10x plus 25 equals 0. So I want you to try both of these, okay? So again, you've got to move that 25 over first, factor it completely. This one you can factor just by putting in the parentheses, okay? So try those two. They have, the answers are going to wind up being a little different than what we saw on the last page. Okay, so for this first one, I'm going to move the 25 over because if I'm going to solve by factoring, I have to do that. And this is what's called difference of squares. If you can write the first term as something squared, 2x squared, and if you can write the second term as something squared, it winds up being the factors wind up being two conjugates. So 2x minus 5, 2x plus 5. So whatever's inside those parentheses when you square it, you're going to add them and then you're going to subtract them. This is just a special factoring. It's called difference of squares, if you want to look it up. Difference of squares. Now I said each one of those equal to 0. Add the 5, divide the 2. I wind up with 5 halves. Subtract the 5 and divide the 2. And you'll see we have opposite answers, right? 5 halves, negative 5 halves. But again, we have two solutions because it's a degree of 2, okay? Kind of neat. So then lastly, the last factoring question we'll do is this one. So this one actually, factor is easy, right? I mean, if you were looking at this one, if you're trying to find two numbers that multiply to give me 25 and had to give me negative 10, well, that's just minus 5 and minus 5. What's different about this one is the solutions. You set that equal to 0, and you get x equals 5, and x equals 5. You've got the same solution. Now, I know what you're thinking. You said, Mr. Shirley, you said if we have a second-degree polynomial, we'd have two solutions. Well, this means we have two repeated solutions. It actually has some neat things that happen when this happens on a graph. We're going to get to graphing these in a few sections, and we'll see something neat that happens when we have repeating solutions. Okay, so those are all the examples you could kind of come across with factoring by grouping. I mean, I'm not factoring by grouping, solving by factor. And we've got to know how to factor. Okay, we have to know how to factor. Even though we could have solved every single one of these we've done so far by the quadratic equation, that doesn't matter. We have to know how to factor. Okay, we have to know how to factor. It's not going to, it's going to be a real bumpy 7 weeks if we do not know how to factor. Okay, that's what he put it. So then the next form of solving I'm going to go over is the square root property, or solving quadratics by the square root property. And I'm going to give you a few examples to try and see if you can recall how to do this. But I'm going to do a basic one first, and then they build on each other, okay? So on the first one, let's do x squared equals 36. And then we'll do 2x squared equals 100. On the third one, let's do, let's say we have 3x squared plus 1 equals, let's do negative 20. And lastly, let's do one right from the book. X plus 2 squared equals negative 7. So I want you to try these 4, okay? And this is solving by the square root property. Again, we know how to do this. If you're in this class, you know how to do this, or you should know how to do it. And attempt to try these using the square root property, okay? Using the square root property. And if you're just lost, sit tight. I will go over them, but I want to give you a few minutes to attempt to try it. It's okay if you fail, okay? It's okay if you get all these wrong. Doesn't matter. The goal is just to see what you know and don't know, and this is a way to assess yourself, to see what you know and don't know at this point, okay? Okay. So the square root property says, look, if you've got to get x squared by itself. This one is set up properly for it, or perfectly, I should say, for it. And then you take the square root of both sides. Okay. And when you do that, when you take the square root to solve, when you do the operation in this manner, you have to attach a plus or minus. Well, the square root of 36 is just 6. So we wind up with two separate answers. Now you can write those two answers in this way, -6 and 6. I didn't write any of the ones before like that, but I wanted to show you if you have two distinct answers, you can just put squiggly brackets and put them in here, separating them with a comma. Okay. This is called set notation. And it's just, hey, we've got these two answers, -6, +6. Now, okay, so the square root method on this one, you need to divide the 2 over, and then you can do it. And it turns into a simplifying a radical, right? Square root of 50. Now, if you know how to simplify a radical, I'm going to show you how to do it with a factor tree. I just break it down into its prime factors. So 2 is prime, 5 and 5 are prime, right? So 5 times 5 times 2 would give me 50. These are its prime factors. And since we're taking a square root, we're looking for matching pairs of factors. Well, the 5s and 5s match. So this winds up being 5 square root. This 2 doesn't match, so it's got to stay underneath. So my two solutions are -5 square root of 2 and +5. You don't have to write the positive, of course, square root of 2. Okay? Those are my two solutions. So let's look at this last one. Or not this last one, this second to last one. Subtract the 1. I wind up with 3x squared equals -21. Divide by 3. I wind up with x squared equals -7. Again, so now I've really made it into this form, right? The goal is to get the x squared by itself. That's happened on all three of these. Now I'm going to take the square root of both sides. And I get x equals plus or minus the square root of -7. Well, the square root of a negative, remember, is imaginary. So this winds up actually being x equals plus or minus I. We can take out an I, right? So I squared of 11. So the two solutions would be I square root of 7 and -I square root of 7. Okay? I square root of 7 and -I square root of 7. Either one. I mean, you could write it like this. The book's going to write it more like this. Okay? The book is going to write it more in that manner. Okay, so now this one's a little different because it's not just a single x squared being squared. It's a whole binomial. So what's nice when it's a whole binomial, you just want to get that binomial by itself. So now we take the square root of both sides. I did not mean to make these the same. So we wind up with x plus 2 equals plus or minus the square root of -7, right? We know the square root of -7 is equals just I square root of 7. And then you move the 2 over. Now, when you move the 2 over, you're going to put it first, -2 plus or minus I square root of 7. And look, we've got a real part and an imaginary part. Can't add those together, okay? So we are done. If you've got a real number and an imaginary number, they're not like terms, we are done, okay? We cannot do anything more. Okay. So the last way to solve these we're going to go over is just the quadratic formula. And again, I assume you know how to do this. The tough part is simplifying the quadratic formula, but I'm going to go over a few different ones that are really kind of set up to do this. So this is solving with the quadratic formula. So we've got, let's say we've got number 1 here, x squared minus 6x plus 10 equals 0. Notice we can't factor this. There's not two numbers that multiply to give me 10 that add to give me -6. Number 2, let's do, let me steal one here. 3x squared minus 6x plus 1. Okay, try those two. So try the quadratic equation on these. Remember, the equation. If you're not sure what it is, Google it real fast. I'll write it down here in a second, but it's just, it's that whole x equals negative b plus or minus the square root, all that fun stuff. Okay. So solve the quadratic formula using the quadratic formula. This is stuff we should know already coming into this class. So it is just a nice review. Okay, let's see here. So solving with the quadratic equation, quadratic formula. Remember, it's x equals negative b plus or minus the square root, b squared minus 4 times a times c all over 2 times a. So we get x equals negative b, so that's going to be negative negative 6. That'll turn out to be a positive 6, right? Square root b squared minus 4 times a times c all 2 times a. I like to solve for what's underneath the radical first. I'm going to kind of make a line here, keep these separated. I like solving for what's underneath the radical first. Negative 6 squared is a positive 36. Negative 4 times 1 times 10, that's negative 40. So this winds up being negative 4. So we get x equals 6 plus or minus the square root of negative 4 all over 2. And then I just start simplifying. It's a fraction with 3 parts. So if we're going to simplify, all 3 parts have to be divisible by the same number. And the square root of negative 4, we've got to simplify first. So this winds up being just 2i over 2, right? Square root of 4 is 2. It's imaginary because it's negative. And then I could divide everything by 2. So I wind up with 3 plus or minus just I. Because 6 divided by 2 is 3. 2 divided by 2 is 1. If you want to write a 1 right there, you're fine. And then that 2 goes away because it's divisible by 1 as well. And again, we can't add those together. We've got a real and imaginary. So those are our 2 answers. You can write it like that, or you could write it as 2 distinct solutions like that. Okay, either one is fine. Okay, either one's fine. And when you check your answer, if one's in one way or the other, it just realize those are the same solution. Okay, and then we've got 3x squared minus 6x plus 1 equals 0. So x equals negative b, I want to put the same b value, plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. So again, I like solving what's underneath the radical first. So I'm just going to do that here. We wind up with 36 minus 12 on this one, right? 36 minus 4 times 3 times 1, so minus 12. So this winds up being that 24, right? So we get x equals 6 plus or minus the square root of 24 all over 6. Again, we can't divide all these by 6. This 24 is not 24. It's the square root of 24, some weird number. So I've got to simplify the 24 first. Now, unlike the one over here, that was a nice, even root, or say even root, nice rational root, right? Simplified out. The 24 doesn't. So I'm going to do that factor tree again on 24. So let's do it up here. So 24 winds up being 8 times 3, and then 2 times 2 times 2. So there's a lot going on with 24. But what matters is the factors are 2, 2, 2, and 3. That's the prime factors of 24. 2 times 2 times 2 times 3. It's a square root, so we're looking for a pair. So a pair of 2's. So we wind up with x equals 6 plus or minus 2. Square root of 2 times 3 is 6, all over 6. Now, I can divide all these by 2. So I wind up with 3 plus or minus, this 2 goes away, 2 divided by 2 is 1, all over 3. Boom. That's our last 2 answers. Okay. Awesome. So for this section, for homework, and again, this is just a good review to remember how to solve and how to factor quadratics. Homework, it's on starts on page 160. And I want you to do 1 through 33. These are all going to be odd. And then skip over and do 65 through 73. And 83 through 103. Odd. It's okay if you did every other odd on these because it's a lot kind of to throw at you in one section, but either one's fine. So do all of them if you've got the time. If not, just hit every other odd. So you've at least seen all of them. This will be on the first test, but more than that, it's going to be almost on every test moving forward. You're going to have to remember how to solve quadratics. Okay, it's going to be a part of that. Okay, so now I'm going to go over section 1.7. I'll ask if you guys have any questions at the end of 1.7. Okay, so if you're sitting there with a question, you can put it in the chat if you want to over there. I'm not sure where your chat is. It's that way. You can put it in the chat if you would like, and I'll get to it. But I'm going to get through 1.7, and then I'll open it up for discussion. Okay.